So today I'm doing a basic receive check on the 10 gig transverter. So I've got it set up over here in the shack using this dish feed as an antenna that goes into the receive input on the 10 gig transverter over here. The IF output of that at 144 megahertz goes into the intermediate transverter 144 to 28, and the output of that ultimately goes over to my HF rig over here, the FT2000. And I've got Spectran running on the computer as a waterfall of the audio spectrum from the receiver. So I don't have a signal generator, a proper piece of test equipment for this frequency, but I do have this weak signal source that I built from an old synthesizer board out of something or other, and added on a stable OCXO for a 10 megahertz reference. So this is quite stable. I've checked this out with the receiver, this GPS locked, and this thing, once it's warmed up, is very stable. And it has warmed up for several minutes, so it should be stable now. I'm expecting that the transverter is not very stable. It's a free-running crystal oscillator, basically. It doesn't have a heater or anything on the crystal there. And this is a 106.5 megahertz, 106.5 megahertz crystal oscillator, multiplied times 96 to get to 10 gigs, 10.224 gigs for the LO in this transverter. So even a very small amount of drift at the oscillator frequency will equal a lot of drift at 10 gigs. So I'm going to go ahead and switch these transverters on from a cold start here. And there's the signal. Well, there's the signal now drifting in here. As you can see and possibly hear the signal in the background, there's quite a bit of drift going on from a cold start. Not really surprising at all for this transverter with a crystal oscillator. That's really to be expected that there would be some drift. Now it's drifting the other way here a little bit. So I'm not going to stand here and wait for all of this warm-up drift to settle out. I expect it's going to drift a few kilohertz here for a few minutes. So I'm just going to stop and leave this running and wait for it to get as stable as it will. And I'll come back and show you ultimately what it's like after it has stabilized. Everything has been on for several minutes now, and this seems to be about as stable as it gets. And as you can see, it's not very stable. It's drifting back and forth 500 hertz or so here at 10 gig. Maybe even a little more than 500 hertz. But remember that at 106.5 megahertz at the crystal oscillator frequency, this is only about 5 or 6 hertz of drift, which wouldn't be bad for a crystal oscillator at VHF. But it's just multiplied up so many times, and the drift gets multiplied as you go up in frequency, so it's not very stable. And this is all coming from the oscillator in the transverter here. Let me just use a QSL card as a fan here to move a little bit of air across that crystal. And as soon as I do that, see the big sudden frequency excursion there? And it comes back. So it's just a question of the crystal oscillator not being very stable. And this is why we GPS lock everything up here at these microwave frequencies. Lock them to a GPS disciplined oscillator, and then they're stable. So I will be doing that eventually. This is just a basic receive test to make sure it is receiving. I'm going to go ahead and put the cover on that transverter and leave it a while and see if it settles down when it's not open to the air in the room and any air movement on the crystal and the oscillator parts, and see if that makes any difference. So I'll do that and be back here in a bit. Okay, so now all I've done is I've put the cover on the transverter so that oscillator is no longer exposed to any air moving around in the room here. and it's quite a remarkable result actually. It's still very slowly drifting down, and it's only been on for about 10 minutes. I suspect the whole transverter is still slowly warming up. But you don't see those rapid shifts like before. It's just a very slow, steady frequency drift. So putting the cover on did wonders for this thing. So here's another interesting effect. I don't know if you can hear the audio here. Let me turn it up a little bit more. If I just move my hand in the vicinity of the dish feed and the signal source down here, hear that frequency change? And that's not drift. That's Doppler shift from something moving in the field of RF. At 10 gigs, it's remarkable how anything that's moving reflects the RF and creates Doppler effects like that. Okay, so anyway, the receive on this thing definitely is working. And I've got one more test I'm going to try here in just a moment. Okay, so just one final little experiment here in this video. This is a piece of test equipment I built a couple of years ago when I was getting started in on this 10 gig journey. This was intended to be an RF power meter and return loss bridge, and also a simple signal generator and portable backyard beacon. Inside, this uses one of the VHF design PLL boards that I talked about as a potential beacon exciter in another video. One of these boards here inside this, and I've got this one set up, programmed with a simple Morse code beacon message, which those boards can do. And here's my little log periodic dipole array antenna, good from 2 to 10 gigs, that I have on this. So this is just sitting in here at the workbench, radiating a signal. And over here in the shack, I've got the transverter still set up, of course. And so we can listen to the beacon. So a couple of things about this. You can still hear the signal weakly when the beacon's not sending. There's enough leakage from that board, and it's just in the other room. And personally, I don't like the keying on this very much. It's a little choppy sounding to me. And also, it's clicky. You can see on the waterfall the width of the signal here with the key clicks. It's not the cleanest thing in any way. Honestly, not too thrilled with these as a beacon, although they do work, and I know there are some on the air. But it's a good test of the transverter. It definitely is receiving, and once I put the cover on, the drift isn't really all that bad either. I do have to keep retuning every minute or so because it's still very slowly drifting in frequency, but not too bad for a crystal oscillator multiplied up to 10 gig for the LO in that thing. So that's it for the basic receive test, and more stuff to come here in the days ahead as I continue to work on testing and improvements to the system.